Hi, this is Jay from caldereriaonline.com. In this second video of this series, I will continue with the complete development of the V-shell mixer. This time I will work on the trunnion shaft and the reinforcement plates. You can check the previous video in this series where I developed the mixing vessel itself. Having a main vessel with an outer diameter of 600 millimeters, this means that the inner diameter of the gusset plates will be also 600 millimeters. Let's say the gusset plates are 8 millimeters thick. The shafts are made of hollow pipe and are designed to have solid ends welded on for the bearings. I have rotated the vessel with the shaft into a position that matches the dialog image. The dimensions are as shown on screen. I will be using the 2 diameter oblique T pattern. I will be using the same main vessel dimensions, but I am considering them as internal dimensions since the gusset plate needs to be bent to a 6 millimeter internal diameter, as I just already said. Thus, I will obtain the reinforcement plate by creating the development of an auxiliary pipe with an internal diameter of 608 millimeters thickness. I only need the shaft development and the shape of the hole from this auxiliary development. The rest will be discarded. So I am already logged in caldereriaonline.com, and before entering any parameters we will check the configuration settings. So in case of D1 and 2, this should be internal, as I will be using the same dimensions for the gusset plates. This is external OK. Trimmer, external is OK. Here we use internal, and the rest is OK, so I save the settings and I will enter the parameters. So this process needs to be run twice. If I once clicking here, that is to get a wraparound template, because I will be using an existing pipe. This will be for the case of the trunnion shaft, and you can check a video on more information about wraparound paper templates and why it is sometimes necessary to run a pattern twice. Please note that the selected pipe sizes, pipe thicknesses, and sheet metal thicknesses are based on my local material availability. Always check the availability of the raw materials you plan to use before creating your pattern. So the first run will be for an existing pipe, that is to get a wraparound template, and I'll calculate the pattern. So in this case, this is not to scale, we will care about this wraparound template. I download this and we see this in my CAD. So here I am in my CAD. I will open my last download, which is this one. And for this case, we will be using this part only to cut a paper template and wrap around my existing pipe to get in the both trunnion shafts. So here I am back in caldereriaonline.com for the second run, that is for the standard pattern. This will be for the reinforcement plate. This will give us the shape of the hole here on this auxiliary pipe we are calculating now, and this hole I will use it to create a reinforcement plate with a width of 130 all around here. So I will offset the hole and I will get thus the reinforcement plate like this. In a separate video I will show an alternative method to calculate a reinforcement plate. So I will calculate the pattern. So now we will care about this part. I download this and we check this in my CAD. So here I am in my CAD. I will open the last download, which is this one. And in this case, we only care about this hole. Actually, I can just make offset 130. Well, and it says it is not possible. So there's a workaround. I will offset to the inside 20 millimeters like this, and so this will be only an auxiliary line for this moment, and I will offset again 150, so we have 130 on the outside like this. So we don't need this, and this part is only for our reference. During the assembly we can have the trunnion shaft coincident with this part here, and this is our reinforcement plate. Thanks for watching. In the next video I will continue with the discharge nozzle. Have a great day.